Exposure. In this section, we're going to look at what makes your photos come out a bit too bright or a bit too dark. How do you control that? A bit of a look at histogram graphs as well. And just a reminder that this is all covered in the exposure section of the course notes booklet that you can buy online. And also there's little plastic summary cards. There's a little exposure section there. Just shows you how to change that brightness as well. But firstly, what actually is exposure? Well, exposure is light falling onto your image sensor, and you can think of it as the entire time the shutter is open, more and more light is landing on there, and it's just collecting more and it's getting brighter and brighter. And hopefully when the right amount of light has gone in there, your photo finishes and you end up with perfect exposure. Obviously half the time that's not what happens, and you end up with incorrect exposure. So underexposed, just not enough light got in there yet and everything's come out looking too dark. Overexposed, too much light got in there and everything just comes out looking too bright. Correct exposure, just the right amount of light. But the problem can be that by the time you get, this part of the photo looking correctly exposed, some other part will still be too dark or too bright. And that's caused by what's called a contrast limitation. All cameras have this problem where they can't see into the bright and into the dark at the same time. So you've got a situation like this one perhaps, where we've got the foreground having correct exposure, but by then those background rocks in the brighter sun, they're now massively overexposed. And you go, well, that doesn't look any good. Maybe we'll set the camera up to get correct exposure for the background. But now, of course, the foreground is too dark, and there's nothing you can do in the one picture to fix that up. You could deliberately take both and merge them together using HDR, high dynamic range, or something like that. There's just nothing you can do to get around that problem of really harsh lighting having such a big difference between being in the bright and in the shadow. But the thing is, when I was standing there looking at that view myself, it looked great. And then you get a picture like that back, and you're left wondering, what is wrong with the camera? It's not particularly that the human eye has some incredible ability to see into the dark and the bright at the same time. It does have a better contrast range than a camera, but still the main thing to remember is that the camera has that variable sized aperture hole in the lens, and your eye has exactly the same thing in your iris or your pupil. The thing is, when you're looking at a scene, the pupil changes depending on where you're looking so that everything looks correct for you. So when you look up here in the bright part of the scene, your pupil would shut right down and cut out all that light, so that would be correctly exposed. But then when you look down in the shadows, your pupil would open up and let more light in, and then the shadows would look correctly exposed. But the thing is, you remember when you looked up to the top, that's what it looked like, and when you look down in the shadows, that's what it looked like. You're kind of just building up a mental picture of the world that seems wonderfully exposed wherever you look, but it's because it's changing a lot. Of course, with a camera though, you're stuck with the one setting for the entire shot, and there are just going to be some bits that are so much brighter that they become overexposed or underexposed, and there's just not a lot you can do. You've just got to remember that cameras can't cope well with scenes that differ too much in their brightness. So really strong lighting, like midday lighting, that's why it's such a bad time to take photos, because the difference of the side that's in the sun and the side that's in the shade just next to it, it's a million times different, and the camera just can't cope. You're going to end up with black shadows or overexposed highlights. So collecting the right amount of light, you can think of it as a volume of light you've got to get into your camera somehow, and it really doesn't matter whether it all comes in at once or if you just gradually let the light trickle in, as long as at the end of the shot you've collected that same total volume, because that total amount of light is what determines how bright your photo is. That brings us to this useful little analogy. This is the size of your aperture hole here. If you make that a really small hole, obviously the light can only gradually trickle in, and it takes the camera quite a long time to collect the amount of light it needs for that correctly exposed photo. So you typically have quite long, slow shutter speeds associated with those tiny little holes. Conversely, if you open the aperture up to a really big hole, like that, the light's able to rush in very quickly, and you typically have quite fast shutter speeds associated with the large aperture holes. That makes sense to that level. But the key thing to realize here is that both of those photos are correctly exposed. They both look exactly the same in terms of brightness, but they're creatively different due to the effects of having different shutter speeds and different apertures. So for any given scene, there's actually a huge range of values you could choose, a whole bunch of different aperture shutter speed pairs that will all end up with correct exposure and the photo will look fine, but you get to choose whether you want long shutter speeds or fast shutter speeds or big aperture holes, small aperture holes, to get the creative effect you want. Like if you wanted a really fast shutter speed to freeze an eagle coming past, well, you can just tell the camera, hey, I want 1,000th of a second for the shutter speed. And the camera will work out and go, gee, I've got to get all that light in 1,000th of a second. I'm going to have to open up that aperture hole really big, and it'll work out the size of the hole and set that for you. Or maybe you're interested in a long, slow shutter speed, like of a waterfall. You want to see all that flowing movement. So you could just tell the camera, hey, I want a 1-second photo. And the camera will then work out that it's going to have to let the light come in slowly through a little hole, and it'll set the size of the hole for you. Or maybe you're not interested in shutter speed at all. You want a particular aperture. We'll learn in another lecture about how the actual aperture links into what's going on with your depth of field. But for now, let's just say you wanted, this much aperture. So if you tell the camera to make the aperture hole that big, it'll then work out the shutter speed has to be this long to go with it. You don't need to try and balance these two things yourself unless you're in manual mode or something, and there's almost no call for that. Unless you're in a studio or a few other things, there's a bit of a misnomer around that, to be a real photographer, you need to use manual mode. Just completely not true. So how do we actually start to shift this balance? How do we unlock some of that creative potential from the camera? Well, yep, that's when you've got to step out of auto mode. So P mode or program mode, that's one step up from auto mode. And as you'll see, that starts to unlock some creative options for us. We'll use this mode as a stepping stone, and sooner or later we'll end up not using P anymore. We'll just start using either aperture or shutter speed, depending on what you're interested in. Now in program mode, when you go and take a picture, the camera automatically suggests a particular aperture shutter speed combination for you that it thinks is about right. Interestingly, it's exactly the same set of values it would have given you in auto mode normally. It's just that if you wanted to, in P mode, if you're brave enough, you're allowed to start scrolling away from those default middle values and try and choose something more creative. So as you scroll one way, you might find that the aperture hole is getting smaller, and because it's getting smaller, the shutter speed will stay open longer for you. Or if you scroll the other way, the aperture might be getting bigger, and therefore the shutter speed gets faster, but it's still giving you the same total amount of light in the end. So this is typically how it works. You touch your shutter button, the camera wakes up, suggests those middle default sort of values for you. That's the shutter speed, 125th of a second. And over here, that f4.5, that's the size of your aperture, but we'll learn later on about what that actually means and how that links to your depth of field. But as you scroll around now, you find that the aperture hole is getting smaller, and because the hole is getting smaller, the shutter has to stay open for longer and longer, so we're still ending up with the same total amount of light. So the brightness of your photo is not changing, you're just choosing how you want that light to come in and having different creative effects now for different apertures and different shutter speeds. Now the great thing about P mode is you're entirely safe. It won't let you scroll off the edge of the earth and start getting incorrectly exposed photos. It'll always keep you within certain limits. Either a shutter speed limit, you'll find the fastest photo your camera can probably do is about 4,000th of a second. Some cameras can do 8,000th of a second, but that's a physical limit. The camera just can't take a photo quicker than that. So if you were scrolling around and got to 4,000th of a second, you just wouldn't be able to scroll anymore. Fair enough. Or if you're going the other way, the slowest, longest shutter speed most cameras can do is 30 seconds. You can take a longer, 2-hour star trail photo, but to get longer than the 30 seconds, you do need to start plugging in external devices. More commonly though, you're going to come up against an aperture limit, because whatever lens you've stuck on the camera, the aperture hole can probably only open this big or go down this small. So you'll be scrolling around and your F numbers will just stop. Fair enough. So how does your camera work out how bright you want the photo to be? Well, it's actually very simple. Inside here, there's a thing called a light meter. And when you half touch your button, and it's trying to find something to focus on, it's also looking at how bright the world is out there. And it just decides how much light it needs to collect to give your photo on average mid brightness. Halfway between being totally black and underexposed or totally white and overexposed, just on average mid brightness. But a lot of cameras have different metering modes in them, matrix metering, evaluative metering, and so on. All those things are doing is just telling the light meter which part of the photo to look at, which part will come out being mid brightness or whatever you tell it to be. So let's take a look at the one that I recommend you use, which is for a Canon evaluative metering, or Nikon calls that matrix metering. Now that's where the light meter is looking at the whole picture overall and making sure it comes out mid brightness or whatever you tell it to. Now that actually works out quite well for most photos because your typical scene actually has about as much dark stuff as it does bright stuff, and on average it's mid brightness. But of course it's not going to be perfect for every situation. Take a look at these examples. So here we have a bird in a tree that's correctly exposed, but it is actually quite bright, isn't it? There's a lot of bright sky back there. So what tends to happen in these situations is that your camera looks at the scene and goes, well, I'm going to collect enough light to be mid brightness overall, and your photo ends up looking a little bit like this, quite dark and drab compared to what you actually wanted. That's because it's giving you a mid brightness photo, but actually what you wanted, the real world, was quite a bright scene. So you need to find a way to tell your camera to make that photo brighter. Another classic problem is when your photo is backlit, like this one. There's so much bright light in the background that the camera just goes, well, I'm going to collect enough to make it a mid-brightness photo for you, and you end up with a shot a bit like that. Your subject just looks like a silhouette. We've all done this before, when you accidentally catch a window in the background of your photo, and your subject is just a dark shape like that. If you think about it, that photo is still mid-brightness overall. Half the photo is black and the other half's white. But the thing we're interested in, our subject, is way too dark. So again, we need to find a way to control this exposure brightness. Quick little detour onto a compact camera. You might have noticed these things just have so many different scene modes these days. There's like pet mode, underwater mode, snowman mode. And I never used to really use those modes because I didn't really understand what they did. But I've since learnt that a huge amount of programming have gone into those different modes, and it is totally worth scrolling to the different setting if you're taking photos of fireworks. Go to fireworks mode. Or, snowman mode. What snowman mode is doing is just saying, hey, I'm in the snow. I expect a lot of bright white stuff around. Collect more light than you were going to. Give me a nice bright white photo, not a dull grey snow. But back on a real camera, maybe you're supposed to use different metering modes. Now, different brands, of course, and different cameras offer different things, but basically you've got quite a few options there normally. But we'll go through them all so you know what they are and why they all exist. But I'll prove to you that you honestly don't need these other three. You can survive quite happily on evaluative or matrix metering and still getting the complete creative control out of your camera. So let's take a look at partial metering. That's where the light meter just looks at the middle region of the photo and makes sure that comes out mid-brightness, and it doesn't look at the outside stuff. So in a situation like this, that would kind of work because it doesn't get blinded by all this extra bright stuff on the outside. What about spot metering? Now, spot metering is lethal. It's one tiny little point. That's all the light meter's allowed to look at, and it bases the whole image off making sure that little point comes out exactly mid-brightness. So that's great if you're pointing at something that's supposed to be mid-brightness. So for a photo like this one, maybe that would actually come out all right because that dot is supposed to be mid-brightness. But what if you missed and you pointed over here instead? The camera will make sure that that part comes out exactly mid-brightness, which just looks terrible. Or if you pointed over here, something that's supposed to be quite dark, then the camera is going to make sure that dark thing comes out being mid-brightness, and you end up with a massively overexposed shot. Most of the time you're just left wondering going, why do they give you such a crazy over-the-top setting that ends in disaster most of the time? Well, it does have a use, but it's designed for in a studio setup, where just before you take a picture of a model or a packet of cornflakes, whatever you're photographing, you'd quickly hold up what's called a grey card in front of your subject, a bit of cardboard or perspex that is exactly mid-brightness, and you'd spot meter off that and go beep, make sure this comes out exactly mid-brightness because it is mid-brightness. Beep, take it away, take the shot, and lo and behold, you end up with perfect exposure every time. Now that's great if you've got a grey card in a studio, but out in the real world, it's just impractical. Some people will usually say about now that they find that if they're photographing, a bird in a tree and it normally comes out being silhouetted, if they change to spot metering and then try it, then it might come out better. Yeah, it probably will come out better, but the problem is it still won't be right. What happens if now it's too bright or it's too dark? Are you supposed to then change to center weighted averaging metering? No. There is a whole system in your camera, everyone's camera, designed to help you control your exposure. Plus minus brightness, exposure compensation. You've all seen this little slider indicator before. It's often on the back of your camera, even inside the viewfinder when you're looking through. It's really important. If you leave it in the middle on 0, that's when your camera is going to collect enough light for your photo to be mid-brightness on average. But if you move it down, -1, -2, it's going to collect less light. Your photo will come out darker. Or if you go +1, +2, then your photo comes out a predictable amount brighter than mid-brightness. Obviously how you change it depends on what camera you have, but most of the time you'll find your camera has a little +- brightness button on it, just like that. Don't get confused by one that looks like that, a little + brightness with a lightning bolt next to it. That's changing the exposure of your flash, something totally different. But you're just looking for a little dedicated +- brightness button. You'll have to press that button in and keep it held in while you scroll one of these wheels, and then you'll find that little marker will move up or down, and then wherever it is when you let go, it'll stay there, and the next photo will be really dark, and so will the next one. In fact, even if you turn your camera off and pull it out again next week and take a picture, it'll still be on -1 or whatever you put it on. So you've got to get in the habit of checking where you've put it. For some other Canon cameras about halfway up their range or better, you don't have to press and hold some awkward button in while you scroll. On these ones, there's a whole wheel dedicated to it right next to your thumb, and anytime you bump that wheel, the photo becomes brighter, darker. It shows you how often you're supposed to be doing this exposure compensation. There's a whole wheel there right next to your thumb. So generally, you take a picture, you look at it on the back of the screen and you say, oh, I think it's a little bit too dark. So then you need to brighten it up. So you'd go hold the little + - exposure compensation in, +1, +2, take the photo again, and then hopefully it comes back looking better. I know that sounds like a little bit of trial and error, but you'll get a whole lot better at judging it, and you won't need to take the incorrect photo first. You'll be able to say, oh, I'm in the snow, it's quite bright, I already need to have it on about +1 2/3 or +2 or whatever it is. So it's really important to be able to control the brightness of your image, not only because the camera gets it wrong sometimes and you need to be able to correct it, but also because it now opens up creative options for you to deliberately make a scene much darker, maybe for a good silhouette, and rich up the colors in a sunset or something, or to really overexpose a photo deliberately and end up with this really bright, washed out effect. But a lot of the time, of course, you actually want to get perfect exposure. And if you want to be really sure, looking at the photo on the back of the camera, it's really hard to tell which one is correctly exposed. Is it this one? Maybe it's that one. Who knows? And to make it worse, you can change the brightness of your LCD screen on the camera. If you put your screen brightness on +10, all of your photos are going to start to look really overexposed. They're not. Your screen brightness is just too high. Also, when there's sun shining around and everything's reflecting and glaring off there, and you can't even see what's on the screen anyway, there's plenty of times where you just can't trust what's on that back screen. So these are the situations when histogram graphs can come in handy. Now, you've probably seen these little graphs from time to time. They just pop up and people are like, what is that and how do I get rid of it? But it's actually very simple to understand and really very useful. And it's the only graph we show you in the entire course, so bear with me. A histogram graph just tells you how much of different brightnesses you have in your picture overall. A spike on the left-hand side of the graph doesn't have anything to do with the left-hand side of your picture or anything like that. It's an overall brightness scale. So going across the bottom, that's your brightness. Going further to the right is getting brighter, and coming back this way to the left is getting darker. So pure black is at this end on the left, and pure white is at the far right-hand end. And the height of the graph at any point is just the amount of that particular brightness you have in your image overall. So we can look at this one and say, well, how much black does this photo have? And you look at it and go, black is at that left-hand end. Oh yeah, there's a fair bit of black there. And then there's nothing really until we get to the mid-brightnesses. There's a huge amount of mid-brightness stuff. In fact, slightly darker than mid-brightness, that big spike. And then there's nothing until we get to the bright stuff. There's a fair bit of bright stuff there. And then there is a tiny little bit of pure white there as well. Now looking at the picture that came from, that makes sense. You can see we've got some black there. We've got a huge amount of slightly darker than mid-brightness stuff. And we've got some bright stuff. And we do have that little bit of white in the highlights just there. So why this graph is useful is at a glance, you can see the true brightness of your image, irrespective of what you might have your screen brightness set to, or if there's sunshine around, you can't tell. You can just look at a graph like this one and say, well look, all the information is shoved down the dark end of that graph. Unless you wanted a very dark photo, that's probably underexposed. You need to brighten it up and take it again. What about this graph? You can see here, there's a huge amount of white, lots and lots of white and lots of bright stuff. And then the graph kind of peters off. You've got no mid-brightness stuff, no blacks, no dark stuff. So that is a very bright photo. So unless that's what you wanted, that's probably an overexposed picture. What you're after with your typical histogram graph is just a good spread. They say most photos should have a little bit of black in the darkest part, and the brightest part of the photo in the highlights are probably just supposed to be white. So it's okay if it kind of gets to the two ends of the graph, but most of the data in the graph you want between the two ends. You can think of it as a goalpost, if you like. You want all the photos safely between the two ends, not so dark that it's still black, or not so bright that you've just blown it out and it's just become white. Don't worry about spikes. People often freak out about that. All a spike is saying is that you've got a lot of that particular brightness in the picture. In this example, there's a fairly big spike there towards the bright end. That's just the water in the background. It's quite bright, and there's a lot of it, so you get a bit of a spike building up in that part. So what do you think the histogram graph would look like if you took a full frame photo of just a zebra skin? So black and white. Obviously the graph's going to look a little bit like this one, where you've got a whole lot of black and then kind of some shades near black, but then nothing until you get to the bright stuff. Some bright stuff and a lot of white. Now you can't just look at a histogram graph on its own and say, oh, that photo's underexposed or overexposed, because it depends on the image. Maybe it's supposed to be a very bright white subject. But generally speaking, you just want your histogram graph safely between those two ends. So to look at your histogram graph, you've normally got to be in review mode, playback mode, looking at a picture you've taken, and then you either hit info or display a couple of times, or for a Nikon, it's up or down, and it just cycles through different pages of information, and one of them will finally bring up your histogram. Don't worry about the one with all the different colors, you're just looking at that white one. That's the overall brightness graph. Okay, so now's probably a good time to go outside and do our first prac session. So pick up your camera, make sure you're in P mode, and then just go and find something to take a photo of. Doesn't really matter what it is. Take a picture. Initially, it should come out being mid-brightness on average. And then work out on your camera where that little plus-minus brightness button is. Press and hold it in and scroll. Do something quite dramatic like +1 or +2. Take the same picture again, and you should definitely see the picture then looks a whole lot brighter. And do a darker one as well, -2, -3. Check out that. Maybe bring up your histogram graph as well and watch all that information shoved down the dark end or move up to the bright end and try and get it just about right, safely between the two. If you think that's all too easy and you've done all that before, a good extension can be to try and take a photo of something that's mostly white, like a sheet of white paper or something. If you take a photo of that, initially it's going to come out being a mid-grey sheet of paper, mid-brightness, and you'll be able to look at it on the back and just say, it's too dark, I'll go +1, take it again. And then it comes back looking brighter, and you might think that's okay. But actually, if you checked your histogram graph, you'd probably find the first photo, the mid brightness, that spike, the histogram will just be basically one big spike in the middle, lots of gray. And you'd say, okay, so you go +1, take it again. That spike will move towards the white end, but it won't be anywhere near it. So you'd have to go, oh, +2, take it again, and the spike would move even further. And you'd probably surprise yourself how far you actually need to scroll to bring that spike near the white end, which is where it's supposed to be if what you're photographing is white. So give that a try. When you come back from that prac, it's time to move on to the next lecture, which is all about aperture and how that affects your depth of field.